Winter storms have always existed. Snow, ice, freezing winds, none of this is new. But what is new is their intensity. In recent years, winter storms have become stronger, more disruptive, and more dangerous than many people expect. Heavier snowfall, deeper freezes, stronger winds, and rapid temperature swings are no longer rare events. They're becoming part of a pattern. And the reason behind this isn't as simple as, it's just cold weather. Before we go deeper, let us know in the comments. Do you feel in your lifetime winter storms have become more extreme? And if you enjoy understanding the hidden systems shaping our planet, make sure to subscribe. At first glance, stronger winter storms seem like a contradiction in a warming world. If the planet is heating up, why are we seeing more intense cold events? The answer lies in how warming reshapes the atmosphere, not in eliminating winter altogether. The first key factor is heat. A warmer planet holds more energy. Warmer air can hold more moisture, significantly more. When temperatures rise, oceans evaporate more water into the atmosphere. That extra moisture doesn't disappear in winter. Instead, when cold air moves in, all that moisture can fall as snow. This is why many modern winter storms produce heavier snowfall than similar storms did decades ago. More moisture means more fuel. The second factor is the jet stream. The jet stream is a fast-moving river of air high in the atmosphere that helps separate warm and cold air masses. Traditionally, it flowed relatively smoothly, keeping Arctic air mostly confined to the north. But the Arctic is warming faster than the rest of the planet. This reduces the temperature difference between the poles and mid-latitudes, the very contrast that keeps the jet stream strong and stable. As that contrast weakens, the jet stream becomes slower and more wavy. Instead of staying in a straight path, it dips and loops. When it dips south, it can drag Arctic air deep into places that aren't used to it. When it stalls, those conditions can last for days or even weeks. This is why cold snaps today often feel longer, sharper, and more persistent. Another major driver is the polar vortex. The polar vortex is not a storm itself, but a large circulation of cold air that normally stays locked over the Arctic. When atmospheric conditions are stable, it remains contained. But disruptions in the upper atmosphere, often linked to warming patterns, can weaken it. When that happens, pieces of the polar vortex can break off and plunge south, bringing extreme cold with them. These events aren't random. They're becoming more frequent as atmospheric stability decreases. There's also the issue of rapid temperature swings. Warmer baseline temperatures don't mean steady warmth. They often mean sharper contrasts. When warm, moist air collides with sudden cold outbreaks, the result is powerful winter storms capable of producing blizzards, ice storms, freezing rain, and dangerous wind chills. And then there's infrastructure. Many regions were built for the winters of the past, not the extremes of today. Power grids, roads, water systems, and buildings often fail not because storms are unprecedented, but because they exceed what systems were designed to handle. This makes modern winter storms feel more catastrophic, even when similar events occurred historically at lower intensity. It's also important to understand that stronger winter storms don't contradict climate change. They fit within it. Climate change isn't about uniform warming everywhere at all times. It's about instability. More energy in the system means more extremes on both ends. Cold events still happen, but when they do, they often arrive with more moisture, stronger winds, and longer-lasting impacts. Perhaps the most dangerous aspect is perception. Humans are good at preparing for gradual change, but terrible at preparing for volatility. When winters fluctuate between mild and extreme, it becomes harder to plan, harder to adapt, and easier to underestimate risk. Winter storms are not just getting colder, they're getting stronger, more complex, and more disruptive because the systems that control them are changing. So when we ask why winter storms are getting stronger, the answer isn't a single cause. It's warmer oceans, a destabilized jet stream, a weakening polar vortex, and an atmosphere loaded with more energy than before. And this is why winter storms feel stronger now.